Find all the given roots, well, all the roots given one root. We're given one imaginary root. I made it a simple imaginary root. Just a real quick comment here. If you are given a binomial imaginary root, you have to have the conjugate as its pair. Then you're going to have to somehow, some way, multiply it out to get something like this to do your division. I'm going to do a little monomial imaginary root. So what is the conjugate to this? Negative 3i. So now I have two roots. How many roots am I going to have total? 4. I already have 2. So now I have to take and go x minus 3i times x plus 3i from these two roots, multiply together, and I'm going to get x squared minus 9i squared. But I squared is negative 1, so that's going to be x squared plus 9. Because it is x squared, I'm going to have to do long division. So we just go like so, taking our time. This time I'm going to make sure I got all the signs correct. Alright. I'm going to underline this because I'm going to divide everything by that. I can go in a little bit now. So x to the 4th divided by x squared is x squared. Every time I write something here, it distributes. So x squared times x squared is x to the 4th. X squared times 9 is 9x squared. I better put it over here since it lines up with this x squared. Now we subtract, so that's minus, that's minus. This will be 0. I get x to the 3rd, because there is nothing there, minus 2x squared. I'm going to bring down the 9x. Now I'm going to take x to the 3rd divided by x squared, and that'll just give me an x. So x times x squared is x to the 3rd. X times 9 is 9x. I'm going to have to put it over here. Then we subtract. Well, this will cancel. This will also cancel, being 0 for both. So this doesn't have anything, so I can just bring it down. And then I can bring down the minus 18. Negative 2x squared divided by x squared is just negative 2. So I'm going to multiply that and get negative 2x squared here. I'm going to get negative 18 here. And hey, when I subtract this, they both cancel like they should. I get 0 like they ought to. If they don't get 0, then I did something wrong, or that's not a real root. So now I have x squared plus 9 times x squared plus x minus 2. This is really rather nice. This right here, normally we have to find possible roots and then do some synthetic division, but it's already an x squared, so I can just either factor or use quadratic formula. And I'm going to factor it. What times what is negative 2 but adds up to 1? X plus 2, x minus 1. And so this is my equation right here. I don't want to write it with the I, so I got to have this. And then my roots, my zeros, they're going to be this one here with the plus or minus 3i. This one here will be a negative 2, and this one here will be a positive 1. And I got, there's my roots. And so there's an example of how to find the roots given an imaginary. We have to assume the conjugate, multiply them out. And again, if the imaginary is something like this, the conjugate is that, and when you multiply it out, it gets a little hefty, but you get a trinomial, and then you got to start dividing by that trinomial. Now we made some mistakes in here, so that's why there's so many scribbles, and that's why I started over. But there it is. Find the conjugate, multiply it out, do the long division, then whatever you get, do what you need to do from there. You need to do synthetic division with possible roots because it's an x to the 3rd, or If it's x squared, can you do factor or quadratic formula?